This video is on Unit 4, Chapter 9, Solving Polynomial Functions, Lesson number 2, Solving Polynomial Functions. So in this lesson, what we're going to look at is finding the value of x. And to remind you here, what we're looking for, if you think back to quadratics, the solution to a quadratic is where the parabola hits the x-axis. And the solution to a polynomial function is also where it hits the x-axis. And that's what the first bullet says. So our zeros, or you might call them the roots or solutions, those are the points at which the function intersects the x-axis. The degree of the polynomial is the same as the number of roots of the function. Some roots are real and some are going to be imaginary. And some are actually going to repeat themselves, which brings in multiplicity, but I'll get to that in a minute. Again, let me repeat what that means here. On that second bullet that said the degree of a polynomial is the same as the number of roots of the function, that means that if it has a degree of 3, if it's a cubic polynomial, then there should be 3 solutions, 3 roots or zeros. The next bullet says there are 3 main methods to solving a polynomial function. The first one's graphing, the second one is factoring, and then the third one's a combination of graphing and synthetic division. Now, in pre-calculus, they don't use the graphing function, but that's something that you'll learn about in pre-calculus if that's what you choose to take. In this class, we are not going to talk about factoring, but we are going to talk about how to solve using graphing and using polysomals. So that's why I've added polysomal out here. You don't normally use polysomal, but I'm going to show you guys how to solve using polysomals. So let's look at the next part of this. And I need for you guys to really kind of look at, don't just write this down, but try to process what this means. There are types of solutions. So your solutions are either real or they are imaginary. And imaginary solutions come in pairs. They come as a group of 2, which is important. If my degree is 2, then that means I only have 2 solutions. And those 2 solutions can either both be real or they can both be imaginary. But what I cannot have is 1 real and 1 imaginary. Because again, imaginary solutions come in pairs. So I can't have just 1. I have to have at least 2 or 4 or 6 or 8 or so on. But they can only come in groups of 2. So for a degree 3, if you've got a degree 3, a cubic function, then you've got 3 solutions. And there's 2 different options here. You either have all of the solutions are real, so 3 real solutions, or you can have 1 real and 2 imaginary. But again, you cannot have 2 real and 1 imaginary because the imaginary solutions come in groups of 2. With a quartic polynomial function, a degree of 4, there's 3 different things that can happen here. They can either all 4 be real solutions. You might have 2 real and 2 imaginary, or you can have 4 imaginary. And then with quintic, a degree of 5, again, they might all 5 be real, or you can have 3 real and 2 imaginary, or 1 real and 4 imaginary. But it all centers around the fact that you can never have 1 imaginary solution or 3 imaginary solutions or 5 imaginary solutions because they just don't come together like that. The next concept is multiplicity. Multiplicity happens when a factor occurs more than once, multiple roots that are the same solution. So we might say if 2 is a solution multiple times, we would say 2 has a multiplicity of, and then however many times it occurs. On a graph, when the function bounces off the x-axis, it creates an even multiplicity. So what that looks like is we might have a cubic function that does something like this. This is one solution, and because this function comes down and bounces off the x-axis, it creates two solutions here. There's one here and two solutions where it bounced. On a graph, the last bullet here says, on a graph, when the function bends as it crosses the x-axis, it creates an odd multiplicity. And what that looks like is this. So it bends as it goes across the x-axis. This creates an odd multiplicity. So this might be 3 solutions, or 5 solutions, or 7 solutions. It creates an odd number of solutions. So graph the function f of x is equal to 3x to the 5th plus 18x to the 4th plus 27x cubed. So let's look at that. Before I read those bullets, we're just going to graph that. So I'm going to go to y equal. I've got something here, so I'm going to clear it out. And I'm going to put in that 3x to the 5th power plus 18x to the 4th power plus 27x to the 3rd power. So a couple things here. This is a quintic function because it has a degree of 5. The highest exponent is a 5. It's a quintic polynomial function. There should be 5 solutions. Now, will it hit the x-axis 5 times? Let's look. It does not hit the x-axis 5 times. It looks like it hits it here and here. Now, because it bounces off of the x-axis at this point right here, I can tell you that there are 2 solutions there, and it bends as it crosses the x-axis here, which means it creates 3 solutions there. So 2 plus 3 equals 5. So all 5 solutions are accounted for just by looking at how it hits the x-axis. Again, when it bounces, it creates 2 or 4 or 6. If it bends, it creates 3, 5, 7, 9, depending on what our degree is on our polynomial. So now let's go back and read what the bullets say. So the solutions are -3 with a multiplicity of 2 and 0 with a multiplicity of 3. So let's just go back and investigate. So at -3, the y value is 0. Think back to the chapter on quadratics. When we were solving by graphing, the x is the solution if the y value is 0. So notice where x is equal to -3, the y is 0. That is a solution. 0 is also a solution because the y value is 0. What the table of ordered pairs doesn't account for is the multiplicity. And that comes up from looking at that graph. At -3, it bounced. So 2 of my 5 answers are -3. And it bends as it crosses at 0. 3 of the solutions are at 0. So we say -3 has a multiplicity of 2, meaning -3 occurs twice. 0 occurred 3 times. So 0 has a multiplicity of 3. And I've already talked about the next bullet. Notice how the graph bounces at the -3 on the x-axis. It bends as it crosses the x-axis at 0. Both cases create multiple solutions at each point. Because one of the solutions is x equals -3, if we add the 3 to both sides, the x plus 3 is what we call a factor. X plus 3 is a factor, and it's a factor twice because the solution occurs 2 times. And because the x is also a factor, and it occurs 3 times. All right. So these two examples that we've got here at the bottom of this first page say to graph each function and identify its zeros. So let's look at example number 1, solving by graphing. I'm going to go to my graph, y equal, clear out that old equation, and I'm going to put in the x to the third power plus x squared minus 2x, and I'm going to hit graph. So it's a cubic function, and I should see 3 answers, and I see 1, 2, and 3 points where this function hits the x-axis. Looks like -2, 0, and 1, and I'm going to double check my table of ordered pairs. At -2, yes, there's a 0. At 0, there's a 0 in the y, and at 1, there's a 0. So my solutions for this first one are -2, 0, and 1. I was looking for 3 solutions. I found 3 solutions. All of them are accounted for. In example number 2, it says f of x is equal to -x to the 4th plus 4x cubed minus 2x squared minus 4x plus 3. Again, the degree on this one is a 4. We have a quartic polynomial, so I'm looking for 4 solutions. I'm going to go to y equal, solving by graphing, plug in your equation. -x to the 4th power plus 4x cubed minus 2x squared minus 4x plus 3. Again, we're looking for 4 solutions. Now, when looking at this, I only see 3. I see 3 points where this blue function hits the x-axis. Looks like maybe -1, a +1, and a 3. -1, 1, and 3. -1, 1, and 3. I was correct. So those are my 3 solutions. -1, 1, and 3. Now, I just said I was looking for 4 solutions. I only have 3. What does that mean? Well, what that means is looking at the graph, this one right here bounced off of the x-axis. So the 1 has a multiplicity of 2. Meaning 1 occurs twice. If we did this, which we don't, I don't need that negative. Your solution set would look like this. -1, 1, 1, and 3. 1 occurs 2 times. Y'all, we don't write it this way because in a solution set, once you've said 1 is an answer, you don't need to repeat yourself. That's why we add this little notation. My solution set is -1, 1, and 3, but 1 has a multiplicity of 2. For clarification. All right, so to solve these polynomial functions without graphing, we're going to use Polysimulator. So the steps here, number 1 is to make sure that the equation is in standard form and says equals 0. So we need a 0 on one side. You're going to press apps and select Polysimulator and select number 1, which is your polynomial root finder. It is your root finder. It's going to find the solutions for us. You want to choose the correct degree of the polynomial. Make sure that a plus bi is selected, then press next, which is graph. Enter the equation and then press solve, again, graph, and then put the solutions in solution set. So number 7 is 2x to the 6th minus 10x to the 5th minus 12x to the 4th. And again, we're looking for 6 solutions. So I'm going to go to my calculator, go to apps, select Polysimulator, and we're going to select number 1, which is your root finder. The degree on number 7 is 6. It has a degree of 6. Notice that when I selected the 6, real and auto automatically X'd out. A plus BI and decimal are highlighted, which is fine. I'm not worrying about any of the rest of that. We're going to click next, which is graph. And then we want to put in the coefficients. So what this means is, what are the coefficients on the terms? So the 6th degree term, what was the number out front? The number out front was a 2. On the 5th degree term, what was the number out front? -10. On the 4th degree term, what was the number in front? -12. Now, we didn't have a 3rd degree or a 2nd degree or a 1st degree or even a constant. So the rest of those are going to stay 0. And then we're going to hit solve. And what you see here are the actual solutions. So one of my x's is a 6, another x is a -1, and then the rest of them are 0. So looking at these answers, my solutions are 6, -1, and 0. And 0 has a multiplicity of 4. So I'm going to put the 6, the -1, and the 0 in, not parentheses, in solution set. And I'm going to make the statement that 0 has a multiplicity of 4. And that's just clarifying that 0 occurred 4 times. Then you got your -1 and your 6, which accounts for all 6 solutions. On number 8, we need to add the 51st before we stick this in the calculator, making sure that it is in standard form. So when I added the 50, it's just going to tack onto the end because it's not like any of the other terms. Going back to Polysimul, I'm going to click on window, which is mode, so I can change my degree. The degree on this one is a 3. Again, making sure in your calculator that the A plus BI is always selected. I'm going to click next. And now this looks different. So it looks like the equation, and you're just going to have to make it look the same. So 1x cubed minus 2x squared minus 25x, and then it's going to be plus 50. And then solve. My answers are -5, 5, and 2. A -5, 5, and 2. And you can shorthand your answer to look like that, a positive and a -5 and a 2. That's all 3 answers accounted for. I want to jump down to number 10. Looking at number 10, I have an 8x cubed minus 1 equals 0. So I'm going to go back to Polysimul, go back to window. Number 10 is also cubic, so next. 8x cubed. Now, I don't have an x squared, so I'm going to put plus 0x squared. I don't even have an x, plus 0x, and then it says minus 1. And when I click on solve here, this is where it gets a little complicated. Because our answers are not real. 2 of our solutions are imaginary, and not only that, they are irrational. Imaginary. So technically, you guys, this 0.433, positive and negative, this represents a radical. So if it's a multiple choice test and you're using Polysimul, this is a radical. But how do we write this answer? Well, the first answer is easy. The first answer is 1/2. So the first answer is just a 1/2, plain and simple. The second one is -1/4. Actually, the second answer and the third answer are identical except for the plus and minus. So -1/4 plus or minus, we're going to say 0.43 I. And those are my three solutions. Let's jump down to number 13. X to the fourth plus 4x cubed minus x squared minus 20 equals -16x. We're going to add the 16x. We're going to make sure that we add it in the right spot. X to the fourth plus 4x cubed minus x squared, then the 16x minus 20 equals 0. Let's put that in the Polysimul. Going back to window, I need to change to a degree of 4. Graph. We're going to put in it switches how it looks. So again, this means what is the number in front of the fourth degree, the third degree, the second degree, the first degree, the constant. So I got a 1, a 4, -1, +16, and then the -20. Solve. And our answers, our four solutions are -5, a +1, and a positive and -2i. -5, a +1, and a positive and -2i for all four of my solutions. So Polysimul can come in handy when solving these polynomial functions. Those are your notes for Chapter 9, Lesson number 2.